We did 5 sums, you are saying, no? Sixth one. The refractive index of glass is 1.5. So mu G is 1.5. And that of water is 1.3. Speed of light in water is 2.25 into 10 raised to 8 meter per second. Find the speed in glass. Refractive index of glass upon water is speed in water upon speed in glass. They are inversely proportional. So speed in glass is V in water, mu in water upon mu G. V in water 2.25 into 10 raised to 8 and 1.3 upon glass 1.5. This equals to 15. 1.5 into 9 is 225. 13 into 9, 117. 9 3s are 27. 11. 11.7 into 10 raised to 8. This will be 15 into 9. 9 5 is a 45. 9. 25 into 9 is this. So 5 into 0 0.3. 0.45. That will be now 0.15. 0.45 upon 0.3. 15 into 15 is 2.25 upon 1.5. 1.5 into 1.5. 13 into 5 is 65. Carry 6. 13 and 6 will be 19. So 1.95 into 10 raised to 8 meter per second. Copy 6.1.
Yes.
Okay. 7th one. Ratio of thickness of strips of two transparent medium is 6:4. Ratio of thickness of two strips. So thickness I am writing as distance of A to that of B is 6/4. A and B thickness ratio 6:4. If it takes same time to pass through both, time taken by A is same as time taken in B. Then refractive, what is the refractive index of B with respect to A? We know that since time taken is same. If you remember, this is nothing but mu. What is time formula I had explained? Mu T upon C, correct? Are you remembering? Time taken is mu T by C. So time is mu into thickness here dA upon C. Here it will be mu of B, thickness of B upon C. C will get cancelled. So mu A upon mu B is dB upon dA. So mu A upon mu B equals to 4 by 6. Therefore, refractive index of B upon A will become 6 by 4. That is refractive index of B with respect to A 3 by 2 equals to 1.5. Any doubt? First formula is mu into thickness upon C. It's called as time taken to travel through that thickness.
Yes, sir.
Yes, done.
Yes.
Yes.
Okay. Eighth one. Light of wavelength 4500 in vacuum. So vacuum I can take lambda air 4500 angstrom. Enters into glass block of refractive index 1.5. What is wavelength in the glass block? Refractive index of glass block is wavelength in air upon wavelength in glass. So 1.5 is 4500 upon lambda in glass. Lambda in glass is 4500 upon 1.5. So lambda in glass will become 15 3s are 45, 3000 angstrom unit. See how simple it comes in the exam. This is exam paper question. Okay. Done?
Yes.
Yes, sir.
Green light of mercury has wavelength of 5.5 in air. What is frequency in megahertz? Frequency megahertz. And time period in microsecond. What is wavelength in glass? If refractive index of glass is 1.5, this we can write mu. Refractive index of glass 1.5. 1 by 1. See, frequency in glass or in air remains constant. Lambda in air given, they want frequency. I know speed is n lambda or mu V is nu lambda. Nu means frequency. So speed of light in air, we should remember they will not give you. So from this nu will become V air upon lambda air. V air is 3 into 10 raised to 8. Lambda air 5.5 into 10 raised to minus 7. That is equals to 30 upon 55 into 10 raised to 15, which is 300 upon 55 into 10 raised to 14 hertz. You can take 5 into 11, 5 into 60. 11 into 5 is 55. Remainder will be 5. So 11 into 4, 44. Now remainder 6. So this 545 will be recurring into 10 raised to 14 hertz. We want in megahertz. So this is 10 raised to 8 into 10 raised to 6 hertz. 10 raised to 6 means 1 mega. So it is 5.45 into 10 raised to 8 megahertz. So we got frequency as 5.45 into 10 raised to 8 megahertz. Time period. Time period is reciprocal of frequency. Time period we want in microsecond. So this is nothing but first in standard unit. I'm taking reciprocal, that is 11 upon 60 into 10 raised to 14. I've just taken reciprocal of this. 11 goes up, 60 upon 14 comes down. So it is 11 upon 6 into 10 raised to 15. 6 into 1 is 6. Remainder will be 550. 6 8s are 48. Remainder 220. 6 3s are 18 into 10 raised to minus 15 second. This 10 raised to minus 15 I'm splitting as minus 9 and minus 6. So therefore it becomes 1.83 into 10 raised to minus 9 microsecond. Please copy this much first. The refractive index of glass is lambda A upon lambda G. Lambda G is lambda A upon refractive index of glass. Lambda air 5.5 into 10 raised to minus 7. Refractive index of glass is 1.5. 5 into 315, 5 into 1155. 3 3s are 9, remainder 2, 6 6 recurring. 6 7 into 10 raised to minus 7.
Yes.
Then the wavelength of monochromatic light in air lambda air 6000 and that in water 4500 angstrom. Frequency we want in water and speed of light in water. See, frequency in water is same as frequency in air. So that means it is VA upon lambda A we can use. V is 3 into 10 raised to 8, you have to remember in air. Lambda convert into meter, 6 into 10 raised to minus 7. That means it is 0.5 into 10 raised to 15. So 5 into 10 raised to 14 hertz. Now velocity in water we want. Lambda is given. Frequency is same. So I can say V in water is frequency in water and air both are same into lambda 1. So therefore it is 5 into 10 raised to 14. This will be 4.5 into 10 raised to minus 7. 5 into 5, 25. 5 fours are 20. 2.5 into 10 raised to plus 7. That is 2.25 into 10 raised to 8 meter per second. Follow? Hello? Follow this one?
Yes, sir.
Okay. In college, they are doing which chapter? Interference or ahead of that polarization?
Interference.
Interference. Sir. Completed?
Yes.
Light wave of frequency 5 into 10 raised to 14 hertz. 10 raised to 14. Pass through liquid in which wavelength is found to be. Pass in liquid where wavelength is found to be 4.5 into 10 raised to minus 7. Find the wavelength of light in vacuum, that means air, refractive index of that liquid, speed, velocity of light in that liquid. Now one by one we can start. Frequency given lambda we want in air. Lambda in air is V in air upon frequency. That is 3 into 10 raised to 8 upon 5 into 10 raised to 14. So 0.6 into 10 raised to 6 minus 6. That means it will be 6 into 10 raised to minus 7 meter, or you can write 6000 angstrom here. Now mu of liquid. Mu of liquid is lambda air upon lambda liquid. Lambda air 4.5 into 10 raised to minus 7. Liquid is air is 6 into 10 raised to minus 7. And liquid 4.5 into 10 raised to minus 7. 15 into 3, 15 into 4, so 1.3. Mu in liquid is V in air upon V in liquid. So V in liquid is V in air upon mu in liquid. So 3 into 10 raised to 8 upon 4 by 3. 9 by 4 into 10 raised to 8. That means 2.25 into 10 raised to 8 meter per second.
Yes.
Light of wavelength is 5000 angstrom unit on a plane mirror. Incident on a plane mirror. So from here it is incident. What are wavelength and frequency of reflected wave? Reflected light. Reflected means it will come back into air only. So lambda and frequency of reflected. For what angle of incidence reflected ray is perpendicular to incident ray? For what angle of incidence reflected ray is perpendicular to incident ray? See first this part. Since in reflection, incident ray and reflected ray both are in same medium. Therefore, lambda reflection is same as lambda incident 5000 angstrom. Frequency is V in air upon lambda in air, that is 3 into 10 raised to 8, 5 into 10 raised to minus 7. 0.6 into 10 raised to 15, 6 into 10 raised to 14 volts. Then for what angle of incidence? Angle of reflection is perpendicular to the incident ray. So angle between incident ray and reflected ray should be 90. So since I plus R should be 90 degree. Perpendicular means incident, reflected, they are perpendicular. But we all know that I is same as R. So I plus I is 90. 2I equals to 90. Therefore, I is 45 degree. For this angle of incidence, reflected will be perpendicular to the incident. Now complete full. Yellow light of wavelength 600 nanometer. Yellow light of wavelength 600 nanometer is incident on boundary separating air and glass. That means this light is incident on glass from air. Find the wavelength and frequency of reflected light and refracted. Wavelength, frequency of reflected light and refracted Lambda, I'm writing R for reflection, R dash for refraction. Find the speed, wavelength, and frequency, all we want. Refractive index of glass is given 1.5. For reflected light, lambda R is same as lambda A, which is 600 nanometer. Speed of reflected light is same as that in air, so 3 into 10 raised to 8 meter per second. Then they want frequency of reflected. This is nothing but dA upon lambda A. So 3 into 10 raised to 8 upon 6 into 10 raised to minus 7. 0.5 into 10 raised to 15 hertz, which is same as 5 into 10 raised to 14 hertz. Now for refracted light, lambda R dash is lambda reflected upon mu of glass. So this is nothing but 600 upon 1.5, 400 nanometer. Then speed of refracted is speed in air upon mu of glass, 3 into 10 raised to 8 upon 1.5. So 2 into 10 raised to 8 meter per second. Then since frequency remains same, therefore frequency of refracted is same as that reflected, which is 5 into 10 raised to 14. Done?
Yes.
Yes.
Now that multiple choice questions. Next one. This one is very important one first. Refractive index of air is 1.0003. So usually it is we take 1, but they are telling take it as 1.003, and vacuum is 1. Thickness of air column. Thickness of air column, which will contain one more wavelength of yellow light than in same thickness of vacuum. So if I take this thickness x in same thickness of vacuum, air column has one more wavelength. What is meaning of one more wavelength? Means one more wave. That means number of wave of air is one more than number of wave in vacuum. This is condition given. Condition followed. In air, there are one more wavelength, means one more wave as compared to number of wave in vacuum. Like in vacuum, if there are 7 wave, then here it is 7 plus 1, 8 wave in same thickness. Hello?
Yes.
Do you know what is wave number?
So is it reciprocal of wavelength?
Correct. Reciprocal of wavelength is called as wave number. So number of wave present in 1 meter is actually wave number 1 upon lambda. In lambda distance, 1 wave. So in 1 distance, 1 upon lambda wave. This number of wave in 1 meter is called wave number 1 upon lambda. So in 2 meter, how many wave? Yes, in 2 meter, how many wave?
Lambda by 2.
No, 2 by lambda. By lambda by 1 meter, 1 by lambda. 2 meter, 2 by lambda. 3 meter, 3 by lambda. No?
Yes.
So if it is x meter, then number of wave will be x upon lambda air plus 1 more is x upon lambda in vacuum. This condition followed.
Yes.
Now lambda in vacuum minus x upon lambda in air equal to 1. This much followed. Hello?
Yes, sir.
This interpretation I did wrong. Number of wave in air is 1 more than in vacuum. So number in air is 1 more than in vacuum. This way it will come. So lambda air minus lambda vacuum is 1. Now copy this. 7 is, if I write 6 plus 1, that means number in air is 1 more than whatever is present in vacuum. If vacuum is 6, air is 7. Vacuum is 8, air is 9. Vacuum is n, air is n plus 1. Copy it in this. See this lambda which is given at the start, that is actually lambda given in vacuum. That means in vacuum they have given this is medium for us, denser medium. This is rarer. Shall I clear everything now? See, first you have understood number of wave in air is 1 more than in vacuum.
Yes.
So whatever is in vacuum plus 1 is in air. So x upon lambda air. Air means denser medium for me. It is lambda in vacuum upon medium is air minus lambda x upon lambda in vacuum. This goes up. X mu a lambda vacuum, x upon lambda vacuum is 1. Therefore, x and lambda vacuum is common. Mu a minus 1 equal to 1. X upon lambda vacuum is given 6000 angstrom. So 6 into 10 raised to minus 7 meter, 1.1230. 3 minus 1 equal to 1. So x is 6 into 10 raised to minus 7 upon, this will become 1, 2, 3, 4. 3 into 10 raised to minus 4. That means 2 into 10 raised to minus 3 meter, which we can say 2 millimeter. So x is 2 millimeter, option A. Okay. Okay. Yes, yes, 1 minute. On hot summer day, refractive index of air is small near the ground and increases with the height from the ground. When light beam is directed horizontally, Huygens principle leads us to conclude that as it travels, the light beam will be where? Beam of light is traveling horizontally. On a hot summer night, refractive index of air is smallest near the ground and increases with the height. That means above refractive index is greater as compared to that on the surface. Refractive index, this side it is denser, rarer, and upper side it becomes denser. So one side will move. If I consider this beam of light coming horizontally, so one medium to another medium, this will move rarer, then this is normal. If we assume the light coming like this horizontally, so this ray 1 is rarer medium will travel faster than that. This will travel fast, this will travel slow because this entire thing is denser medium. So one which is traveling faster will travel large distance as compared to this following. So at some point, distance covered by this will be small, this way will get light waveform. So that will conclude that light beam will move upwards because this is moving slow. By the time it reaches here only. So it will move upward. Hello? So this is coming like this, and this is moving slow, faster. This is moving slow, so it will cover low distance. So it will bend upward. If you join this, this will be the wavefront. It will move upward. Third, so simple sum was asked in NEET 2019. Then also many students made mistake. Blindly you can say which color has got maximum wavelength, red or not?
Yes, sir.
So direct answer C. Done. Define optical path. So optical means light. Light traveling in medium is called as optical path. If a light ray travels distance d in a medium. If a light ray travels distance d in a medium whose refractive index with respect to air is n, then product nt is called as optical path traveled by light. If it is air, then distance will be d. If it is with refractive index n, then it is nd. This nd is called optical path. Just copy, then we'll see what will be optical path difference. If light ray travels distance d in a medium of refractive index n, then optical path is nd. Completed?
Yes, sir.
So now we'll prove how it is nd. let n be refractive index of medium with respect to air, and v be its speed in that medium. Therefore, time taken to travel distance d in medium, comma t1 equals to distance upon speed. Speed is v in air, that is c, upon refractive index. Therefore, T1 will be nd upon c. Let this be equation 1. So, time taken to cover distance d in medium is nd upon c. Please copy first paragraph. Yeah, can I clear?
Yes.
Okay. In same time t1, distance traveled in air, comma t equals to speed into time t1. So distance c, time taken we got as nd upon c. So distance covered is nd. So in same time, distance covered in air will become nd. Thus we can see if it travels distance d in medium, then it travels nd in air. Correct? So if I want optical path difference, then nd is the distance in air and d is the distance in medium. So it will become n into d into n minus 1 is called optical path difference. Complete till end. All numericals solved one, please practice. Now we are starting with interference of light. Easy chapter it is. So suppose this is one point and a wave starts from here and reaches at this point. Same way second also comes here at this point. Wave means disturbance. So both the wave will produce disturbance for this particle, or only one wave will produce, or only second wave will produce. Yes. If at a point in a medium, two waves reach simultaneously, then both will produce disturbance, or only one will produce, first one, or only second one, or none of these will produce.
Sir, could you repeat?
I said when this at this is point, one wave comes from behind, reaches to that point P, second also comes simultaneously. So both will produce displacement, or only first, or only second, or none. Both will produce. This is one classroom. This is suppose another classroom. This is third classroom. Lecture are to be started at 7. Three teachers entered simultaneously. Is it that first teacher will say, I will speak 7 to 7:30? You people please don't create any disturbance. So second one said, that means 7:30 to 8 I will get the chance. You people will not speak. Third said, then 8 to 8:30 I will get the chance. You people don't speak. Will it happen that way? Or all the three teachers will start disturbing the students simultaneously, assuming that Bajuwala class में nobody is there. So if one classroom is having common wall with the other classroom, then students sitting here may find some disturbance. If this teacher is speaking physics, this is also telling physics, बीच वाले को physics सुनाई देगा ज़्यादा. But इधर suppose physics आया, इधर से chemistry, तो इसको cocktail लग गया, कुछ समझेगा नहीं. So same way here, when two or more than two wave arrives at a point simultaneously, then each wave will produce its own displacement, as if other waves are absent, and resultant displacement is vector sum of displacement produced by each wave, which is given by a1 square plus a2 square plus 2 times a1 a2 cosine of angle between them, which is nothing but parallelogram law of vector addition. This is known as principle of superposition. Again I am repeating. When two or more than two waves arrives at a point simultaneously, then each wave produces its own displacement, as if other waves are absent. The resultant displacement is the vector sum of displacements produced by each waves. This is known as principle of superposition of waves. Followed, what is principle of superposition? Hello? Hello?
Yes, sir.
Okay, right. Vector sum means parallelogram law. What? Hello?
Yes, sir.
Yes, that's right.
Yes.
So when two waves arrive at a point simultaneously, each wave produces its own displacement as if other waves are absent. Resultant displacement is the vector sum of each wave. This is known as principle of superposition of waves. This is called crest or trough.
Yes.
Crest. And what about this?
Sir.
Trough. So when crest and crest coincides with each other, then resultant will be double the crest. Huh? Like if this is A, it will become 2A. Correct or not?
Yes.
When two waves arrives at a point simultaneously, if crest coincides with crest and trough coincides with trough, then resultant amplitude will be maximum. Correct?
So we did it in oscillation.
Same, no? Oscillation and this concept of superposition is same. So crest will coincide with crest, trough will trough, resultant will be maximum. This type of interference is called constructive interference. What is name of this interference? Constructive. And resultant point will be bright point. Any doubt in this? But when two waves arrive at a point in opposite phase, then resultant will be minimum or zero. If both are same, it will become zero. There is some difference, then something will remain. Such interference is called as destructive interference, and point obtained is called as dark point. Alternate formation of bright and dark is called as interference pattern of light. Under what condition this will happen, that we'll see after this. Have you followed first? Interference pattern means what? Suppose this is screen, I should get alternately bright, dark, bright, dark. This pattern is called as interference pattern of light. Not at random. First bright, 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 then dark, dark, dark. This won't do. Clear?
Yes.
Right. Explain interference pattern of light. Explain interference pattern of light. When two light waves arrives at a point simultaneously in phase with each other, then crests coincides with crests and troughs coincides with trough. Hence, resultant amplitude is maximum. Thus, intensity of light is maximum. Such an interference is called as constructive interference, and point is called as bright point. Complete this much. Written for this much. Next paragraph, right? When two light waves arrives at a point simultaneously in opposite phase, then crest due to one wave coincides with trough due to other wave. Hence, resultant amplitude is minimum or zero. Hence, resultant amplitude is minimum or zero. Such an interference is called as destructive interference. And point is called as dark point. The alternate formation of constructive and destructive interference is called as interference pattern of light. When two light waves arrives at a point simultaneously in opposite phase, Then crest due to one wave coincide with trough due to other wave. Hence resultant amplitude is minimum or zero. Such an interference is called as destructive interference and point is called as dark point. The alternate formation of constructive and destructive interference is called as interference pattern of light. Okay. So that's all for today. Tuesday, Wednesday again will continue. By Friday, this chapter will also get over. Then your exam is starting from 27th, na?